Okay guys, let's get into chapter 9.1 here, properties of radicals. This is an important chapter and it's got a lot of stuff in it, so we're going to spend a few days on this. Okay, so first let's start with the product property here. The square root of a times b is the same as the square root of a times the square root of b. Well, what does that mean in numbers? Well, the square root of 9 times 5 is the same as the square root of 9 times the square root of 5. So, and the reason we broke it up like that is that the square root of 9 can then become 3, and that's 3 multiplied by the root of 5. Now, there's no perfect square root of 5, and so we're going to leave 5 underneath the radical, and so that's going to be 3 root 5. Or let's look at another example here. The square root of 108. Well, we want to start looking when our factor trees say 36 and 3. I want to start looking for perfect squares if I'm using square roots, or perfect cubes if I'm using cube roots. So that's the same as the square root of 36 times 3. And then really that would be the square root of 36 times the square root of 3. And then the square root of 36 is 6 root 3. Okay, so we would simplify the square root of 108 into 6 root 3. Let's look at, say, something like 9x cubed. Well, that's really the, let me erase here. That's really the square root of 9 times x squared times x, because x squared times x is x cubed. And so then we could break that up into square root of 9 times the square root of x squared times the square root of x. Okay, so what's the square root of 9? 3. What's the square root of x squared? X. Notice x escapes the radical there, okay, and the radical's gone. The square root of something squared is just that thing, right? Imagine if x was 2, 2 squared is 4, the square root of 4 is 2. It just became whatever x is, right? Okay, and then I still have the square root of x left. So our answer would be 3x the root of x. 3x times the root of x. Okay, so we're going to look for perfect squares and try and escape all the perfect squares, preferably the largest perfect square, from the radical when we go to simplify our answer. Okay, let's keep going here, and let's look now at one more of these, and then we'll get into the quotient property. For example, if I had 75, the square root of 75n to the 5th, well, how do I want to simplify that? Well, that's really the same as the square root of 3 times 25. And if I wanted, I could break n to the 5th up into n squared times n squared times n. In other words, n to the 5th is really n squared times n squared times n. Or we can look at it as n to the 4th times n too if we'd like. But I'm just going to break it up here into its, try and get to its prime factors as we do this, okay? Okay, so let's simplify further, okay? I'm just going to put this in order here. 25 first, n squared times 3 times n. Okay, and really what this is the same as is the square root of 25 times the square root of n squared times the square root of n squared times the square root of 3 times the square root of n. So now we're applying essentially the radical to each of those products that are multiplied. And we broke it up into, say, perfect squares that I can pull out. Notice these first ones here. I'm going to be able to escape something from the radical, whereas on these two, I won't. And we'll see how that looks here in a minute. Okay, what's the square root of 25? Well, 5. What's the square root of n squared? N. What's the square? And I like to cross them out as I go. What's the square root of n squared again? N. And then if these two are still left under the radical, I can keep them both under the radical 3 times n, which is essentially 3n. Okay? And neither 3 is a perfect square, nor the square root of n can be escaped. Okay? Okay, and what's now n times n? Well, n squared. So it'd be 5n squared times the root of 3n. Okay. Okay, so in this chapter, this is kind of an important skill, and you're going to want to practice it as you go through it. And I'll probably add some supplemental stuff to it as we go. Okay, so let's also look here at the quotient property, which is that the square root of a over b is the same as the square root of a over the square root of b. In other words, just like we did with the products, we can do with the quotients. If they're both underneath the radical, we can apply that radical to each of the quotients individually. For example, if you look below, the square root of 3/4, if they're both underneath the radical, well, then I can put one of the radical to each of them, and then I can say the square root of 3 over, well, what's the square root of 4? 2. So then I escaped essentially that 2 from the radical. So my most simplified answer here would be this root 3 over 2. Okay. Okay, so let's try a couple like this. Let me erase. The square root of 1564. So let's start with the fairly straightforward one. Well, let's move the radical to each. The square root of 15 over the square root of 64. So that's the square root of 15 has no perfect squares hiding in there, so I leave it as the square root of 15. And what's the square root of 64? Well, 8. What number multiplied by itself is 64? 8. So we'd simplify that into the root 15 over 8. That's our answer, okay? Let's do another one. The square root of 81 over x squared. Well, that's the same as the square root of 81 over the square root of x squared. Square root of 81 is 9. Square root of x squared is x, so my answer is 9 over x. Or say C, negative 17 over 100. Well, that's the same as negative square root of 17 over the square root of 100. So that would be negative the square root of 17, and then the square root of 100 is 10. So that would be negative square root of 17 over 10. And notice that negative just stays out front, and then whatever our answer is then multiplied by that negative out front. Okay, so this is a similar property to the product property, except we're kind of applying the same ideas now with division. And we can break up that radical, and then we want to try and pull any perfect square, say, out as we do that. Okay.